Hello, Chemistry 11. This is Mr. Chan, and this is the second lesson in regards to uncertainty in our measurements. Now, the last day's lesson, we talked about the reason for uncertainty and the definitions of things like uncertainty and relative uncertainty. And we left off with the idea of significant digits. And what significant digits are basically all the important numbers in your measurement. Now, today's lesson, I want to focus on, well, how do we know what digits are important? Now, when you take a look here, there are 5 general rules in determining sig figs. Now, the one thing is the first 3 rules. These are the ones that are most commonly used. So it's used most. And usually rule number 4 and 5 is used rarely. Okay, so what happens is when you are figuring out sig figs, usually you use rules numbers 1, 2, and 3 just to is most commonly used. Now, let's say, for example, let's say if I were to ask you, what is the number of sig figs in, let's say, the number 6040302. Now, so basically it's saying how many digits are important in this measurement. Now, if we take a look, it says rule number 1, all non-zero digits are significant. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are considered important. So in this case, if we look at number 6, 6 is important, number 4 is important, number 3 is important, and number 2 is important. And these ones, you fall under rule number 1. Okay, so these ones fall under rule 1. Now, if you take a look at the zeros, the zeros fall under rule number 2. It says zeros placed between significant digits called interior zeros are significant. So they are important. So in this case, if we look at our example here, if I were to look at, let's say here, number 0, 0, 0, these 3 are important as well. Now, so what happens is all of the digits have to be accounted for in the rules. And so in this case, because the zeros are important, and if I look at all of my check marks, what I can say is in this number 6040302, there are 7 significant digits. So these 7 digits I have to take in consideration when I'm doing my calculations. Now, let's say, for example, here, let's give you another one. Let's say we have 4.1020 times 10 to the 5. Now, if we're using exponential numbers and scientific notation, one thing you have to recognize is the times 10 to the negative 5. This is not counted. And why it is not counted is because the times 10 to the negative 5 only tells you how many times the decimal place has been moved. It has nothing to do with the actual measurement itself. So what we want to do is, again, we want to focus on the actual measurement. So this one we need to focus on. So what we do is, again, we go through rules numbers 1, 2, 3, 4, and 5. So if we take a look at it, rule number 1, it says all non-zero digits are significant or are important. So that's this one here, the 4, the 1, and the 2, just like our last example. Now it says rule number 2, zeros placed between significant digits. So in this case, the 0 here in between the 1 and the 2 is considered important. Now, how about the last 0 right after the 2? It says zeros at the end of a number and to the right of the decimal place are significant. So in this case, this last 0, since it is to the right of the decimal place at the end of a number, this is also important as well. So what happens is, if you take a look, because I have 5 check marks, so what you have is 5 significant digits or significant figures. Okay, so that's what this rule of sig figs is basically which digits are important, are included in the measurement. Now, if you want to take a look, what you can do is quickly go through these examples A, B, C, D, E, F, G, H. And what you can do is pause the video right here and try it out for yourself, and then turn the video back on just to see if your answers matched. Welcome back. And what you have is, I'm just going to quickly write down all of the number of sig figs. 1, 2, 3, 4, 5. Here is 6, 6, 3, and 4. All right, so hopefully you got these correct. And again, what you want to do is you want to follow rules, go through each number and go through rules numbers 1, 2, 3, 4, and 5. Okay. Now, why are sig figs important? Because what this does is allows you to figure out how many digits you take in your calculator. A lot of times, back in grade 8, grade 9, grade 10, some of you would do a calculation on the computer or a calculator, and you would ask, oh, how many decimal places should I take? Where should I round off? So with the idea of sig figs, what this does is that it gives you the skills to figure out how many decimal places you will need when you're doing a measurement. So when we round off, okay, so round off the following numbers to the designated sig figs, and we use scientific notation if necessary. Now, for example, let's say we round off to 5 sig figs. So what you have here is, let's say you have 234.676. What you do to figure this out is start on the left with the first sig fig. I'll just use SF. Now, what do I mean by this? So we have 234.676. So what I want to do is start on the left with the first sig figs, in this case, the 2. So I go 1, 2, 3, 4, 5. That's where I want to end off. Now, what do I do with the 6? In this case, this is where you round up or down. And in this case, we round up. So we have 234.68. And that's what we do with rounding with sig figs. Now, let's say we have this second example, 999.95. So how do we deal with that? So what we do is we go, okay, 999.95. Again, we start with the left. So we have 1, 2, 3, 4. Now, what do I do with the 5? So what you can do is we round up. Okay, so what we could say is here, we round up. So what the answer would be 1,000 with a decimal place. or 1.000 times 10 to the 3. Okay. Now, why did I emphasize the decimal place? Because of rule number 4, talking about decimal places. Okay. Now, my suggestion would be this. If you're ever in doubt with the zeros and whether or not they count, my recommendation would be convert your answer to proper, and the key word is proper scientific notation. Because with proper scientific notation, any digit that you write in the decimal portion will be considered significant. Okay, but both answers are correct. It's whatever you feel comfortable with. Now, when some general rules for sig figs when we multiply and divide. So in this case, the result of multiplication and or division carry no more sig figs than the least precisely known quantity in the calculation, or the fewest number of sig figs. Now, I have 3 examples I want to give you. So example number 1 is this one here. So 14 times 202. So if you were to punch that into your calculator, you would go 14 times 202. So what you get is a 2828. Now, back in grade 8, grade 9, grade 10, that was basically it. But now what you need to do is you need to take a look at the original numbers. The 14 here, what you have is you have 2 sig figs. The 202 is 3 sig figs. So what happens in this case is this number, what happens is that it needs 2 sig figs so that it will match up here. Okay, so how do we change this to 2 sig figs? Is by following this rounding. Remember, we start on the left with the first sig fig. Okay, now, so what I'm going to do is I'm going to pause it here. I'm going to let you try to figure it out before we move on. Okay, so hopefully what you've done is you started with the left. So you start with 1, 2. And what you have is you have, again, you will have either 2800 or 2.8 times 10 to the 3. Okay, so again, when you were counting the rounding off, you started on the left, and then you ended off at the 8. So you had to figure out, what do I do with a 2.8, and you round down. Now, let's say for this one, if we take this number, again, what you have is 22.4 times 8.3 divided by 1.142 times 0.0020. And what I got was you would get 81,401.05. Again, the next step is, what do you want to do? And you need to check the number of sig figs of each of the numbers. So in this case, you have 3 sig figs in 22.4, 2 sig figs with 8.3, 4 sig figs with 1.142, and 2 sig figs with 0.0020. So again, in this case, I need 2 sig figs so that this number of sig figs matches up. So again, what do? You start with the left, 1, 2. And then what you do with the 4 afterwards is you round down. So what you would have is 81,000 or 8.1 times 10 to the 4. Now, a common mistake that some people say is, hey, I need 2 sig figs. So Mr. Chan, I'll just write 81. And unfortunately, this is very wrong. You might say there is 2 sig figs. Yes, but the units are off or the place values are off. You have 81,000. Okay, 81 just means you have 81. Okay, so just a mistake that you just need to be very careful of. Now, how about if we had exponential numbers? Okay, so in this particular case, if we were to do it, you can do it in your calculator, but what I'm going to do is break it apart and do it like how I approached last day's lesson. So last day's lesson, remember when we did exponents, when we multiply or divide, we add or subtract exponents. So what I'm going to do is I'm going to show it to you. Okay, so if I go down here, so in this case, what I would do is break it apart. So I would have 15.0 divided by 3.5, and then multiply it by 10 to the negative 6 minus negative 8. Now, in this case, I have 15.0 divided by 3.5. So I get an answer of 4.286 times 10 to the 2. Now, again, if you take a look, the number of sig figs should be 2 because of the 3.5. The 3.5 has 2 sig figs. The 15.0 has 3 sig figs. So I need 1, 2. And so what my real answer would be 4.3 times 10 to the 2. Okay. Now, how about addition and subtraction? Addition and subtraction, what happens is the number of sig figs, the addition of subtraction, must be expressed with the same number of decimal places as the term carrying the smallest number of decimal places, or the least precise number. Now, again, let me go through a few examples with you. So the first one would be 7.5 plus 4.6. So I'm just going to rewrite it here. So I have 7.5 plus 4.60. Now in this case, the 7.5 has 1 decimal. The 4.60 has 2 decimals. So if I were to add this up, this would be 12.10. And in this case, I need 1 decimal. I'll just say deci. Why? Is so that it matches up with the first number that has 1 decimal. So my true answer here would be 12.1. Okay. Now, again, I'm emphasizing the fact that it is decimals. When you multiply and divide, it is sig figs. Okay. So when you're adding and subtracting, it's the smallest number of decimal places. Now, let me throw a couple of other examples here. Let's say you have a variety of steps. Like say for this example, you have a subtraction inside the brackets, and then you have division outside the brackets. So how do we figure this out is we use BEDMAS. So in this case, we use BEDMAS. You remember that from Math 9, I hope. So what that means is we do everything in the brackets first, and then we move on. So in this case, if I were to do this, this answer would be 0.003, okay, and divided by 13.36. Now, why did I keep 0.003 is because there are 3 decimals, okay, 3 decimals here, so you need 3 decimals in your answer. Now, that's the first step is done. The second step here is now, because there's division, in this case, you have 1 sig fig divided by a number with 4 sig figs. So your final answer should have 1 sig fig. So in this case, it would be 0.0002 or 2 times 10 to the negative 4. Okay. So in a scenario like this, where you have multiple steps, you have a subtraction and a division, you follow BEDMAS and you round off at each individual step. Okay. Now, the last one is, let's say, throw a little bit trickier. Let's use exponential numbers. Now, in this particular case, you have noticed something is times 10 to the 4 and times 10 to the 2. Now, what you can do is pause it here and try to figure this out, all right, just to see what your answer is. And then what you can do is, once you come up with your answer, restart, and what I can do is explain how you get the true answer. Okay. Welcome back. Now, when we talk about this, because you're doing addition of exponential numbers, you remember with scientific notation, when you do addition and subtraction, you have to make sure that the exponents are the same. So in this particular case, what we can do is we have to make sure that our exponents are the same first. So what we can do is, I'm just going to rewrite it in a different form. So we have 7.63 times 10 to the 4. And then we add it to, in this case, I'm going to change the 3.4 times 10 to the 2 to 3.4 times, change it to 10 to the 4. So I'll move it 1, 2. So I have 0.034 times 10 to the 4. Now that we have our exponents the same, now we can add this up. So I get 7.664 times 10 to the 4. Now we take a look. Our first number had 2 decimals. Our second number had 3 decimals. So our final answer needs 2 decimals, because what you want to do is match it up here. Okay, so the correct answer with the correct number of sig figs in this case is, since we need 2 decimals, we cut it right here. And so your answer would be 7.66 times 10 to the 4. Okay. Now, some of you might say, well, Mr. Chan, how about I change it to 10 to the 2? Well, I can do that. I'm going to put it in a different color here. So we can change both exponents to 10 to the 2. So in this case, the first number would be 763 times 10 to the 2. And then you have 3.4 times 10 to the 2. Now, if we do the answer here, it would be 766.4 times 10 to the 2. Now, if we look at the number here, again, the process, in this particular number, you have 0 decimal. Here you have 1 decimal. And in your final answer, you need 0 decimal sort of to match up. Okay, so in this case, the answer would be 7.766 times 10 to the 2. Now, at this point, you are happy because you have got the correct number of sig figs. Now, some of you might say, well, then, Mr. Chan, how you get 7.66 times 10 to the 4 as what we did in the first half of this example? Well, we move the decimal place, 1, 2, oopsie. And so what we get is 7.66 times 10 to the 4. Okay? And so this is how we get it the same. So it doesn't matter which exponential number you choose. You can choose to change it to 7 times 10 to the 4 or times 10 to the 2. What you will get is you'll get the exact same answer. Now, common confusion is this. If you choose to do 10 to the 2, what do you do first? You should always round off to the correct number of decimal places first before you move the decimal place. So in this case, if you look back, it was 766 times 10 to the 2. I made sure the correct number of digits was there. Then I moved the decimal place. It is always that step. Check to have the correct number of digits first, and then you can move the decimal place, not the other way around. The common mistake is people move the decimal place first, and then they round. The answer is no, you round first, and then you move the decimal place after you finish rounding. All right, ladies and gentlemen, there is homework that is going to be assigned in class, so I encourage you to come to class and check to see what homework is assigned. All right, folks, thank you very much. Have a good day. Bye-bye.